When dy dx is easy to find for a equation like this, or in this case, we should use f prime x. That is 6x squared minus 12x, okay, plus 6. Okay, and for stationary point, always write this statement, okay? F prime x is equals to 0. So I have 6x squared minus 2x plus 1 equals to 0. X equals to 1 is my stationary point. And what is the y? The y is equals to, I sub it in, 2 minus 6 plus 6 minus 5, that will be equals to negative 3. So I have 1 comma negative 3 as my stationary point. Okay, now I always like to use the second derivative test for easy questions like this. I differentiate this against 12x minus 12. But I realize that when I sub x equals to 1, my f double prime x is equals to 12 minus 12. And that is equals to 0. So remember, the second derivative test will give you no conclusion if it's equals to 0. Then you have to use the first derivative test. Okay, so how do I do the first derivative test? Draw something like a tic-tac-toe. This will suffice already. This is x, this is my dy dx, and then this is my tangent. Okay, my x value is 1, the dy dx is 0, and the tangent is flat. On the left side of 1 is called 1 minus, on the right side of 1 is called 1 plus. Okay, where is my dy dx? That would be here. I need to sub in 1 minus into my dy dx. 1 minus is a value that is close to 1 but lesser than 1, so that I would probably use 0.9 to sub into my dy dx. Okay, 6 bracket 0.9 square minus 12 bracket 0.9 plus 6, and it is a positive value, so I put a plus and the tangent is going up. Now I go back to my calculator and I change all the 0.9 to 1.1. Okay, and then go to the left again, 1.1. Okay, and I realize that it's also positive. Okay, now what does this mean? This means that it's a flat up kind of graph. It looks like this. Okay, it will be stationary for a while over here. So I can say that 1, negative 3 is a point of inflection. Okay, actually 80% of the time when you got second derivative equals to 0, it will be a point of inflection. But of course, you need to show using your first derivative how you arrive at the point of inflection.